In this video, we are going to learn how to find holes and x and y intercepts of rational functions. So here we have a graph, and that is the graph of the function displayed here for f of x. So if you remember, vertical asymptotes typically come from the denominator. We know that we have one here at x equals -4, and that's the only one we have. Now, if you look at the denominator, we have x plus 4, which makes sense. That's where this vertical asymptote comes from. But the x plus 2, we don't have a vertical asymptote at x equals -2, but instead you can see we have a hole. And the reason we have a hole is because if you look closer at the function in its factored form, two of the factors are going to cancel out. X plus 2 divided by x plus 2 is 1. And so when it multiplies, we're just left with the function x minus 3 over x plus 4. So at the x value of x, whatever makes x plus 2 equals 0, so x equals -2, we have a hole. So to find the y value algebraically, you use the reduced function, x plus 3 over x plus 4, and you just plop in -2 and simplify. So -2 minus 5 over -2 plus 4, so that's -7 over 2, or about -3.5, which is approximately the y value that we have. For the vertical asymptote, as we said, we had x equals -4. That's from the leftover. For the horizontal asymptote, we can see that we have a line at y equals 1 right here, right? That's where y equals 1 horizontally. And the way that we can find that, if you remember, is by looking at the leading coefficients of our function because the exponents are the same. They're both 1. 1 over 1 is 1. All right, let's practice some more. Let's just start by finding x-intercepts algebraically. So to find x-intercepts, you're going to factor. So what multiplies to -6 that adds to -1? That would be -3 and +2. And in the denominator, what multiplies to 8 that adds to 6? That would be 4 and 2. Alrighty, here this is going to reduce. X plus 2 divided by x plus 2 is 1. So we're left with x minus 3 over x plus 4. For x-intercepts, remember, you set your equation equal to 0, and then you solve for x. If I wanted to go ahead and solve this, I would multiply both sides by x plus 4 to get rid of the denominator. Okay, so that would get rid of the denominator over here. Anything times 0 is still 0, so I have x minus 3 equals 0. Okay, add 3 to both sides, I get x equals 3. So that's the x-intercept. I have 3, 0 as the x-intercept. Over here, we would do the same thing. We're going to factor. I can pull out an x. I'm left with x squared minus 4. In the denominator, we can pull out a -3x, left with x minus 3. Yep, looks good. I do have some cancellations here. I have x divided by x is 1. So now I'm going to keep factoring. This is x plus 2 times x minus 2, right? X squared minus 4 factors into that, over -3 times x minus 3. So remember, we're finding just the x-intercept. And in order to do that, we just have to set our equation equal to 0 and solve. So x plus 2 times x minus 2 over negative 3 times x minus 3 equals 0. Once again, I'm just going to multiply by the denominator on both sides. And that gets rid of it. 0 times anything is still 0. And so I have x plus 2 times x minus 2 equals 0. So to solve that, we have negative 2 or positive 2. So we have two x-intercepts. We have one at negative 2, 0, and we have one at 2, 0. Let's talk about finding y-intercepts. This is a lot easier. To find a y-intercept, instead of making y equals 0 or f of x equals 0, now we make x equals 0 and we solve. So when I do that, I get 0 squared minus 0 minus 6 over 0 squared plus 6 times 0 plus 8. Well, that's 0, 0, 0, 0. I'm left with negative 6 over 8, which simplifies to negative 3/4. So when x is 0, y is negative 3/4. Same thing's going to happen over here. When I plug in x equals 0 and for x, I'm left with 0 cubed minus 4 times 0 over negative 3 times 0 squared minus 9 times 0, which is 0. So when x is 0, y is 0. Okay. Here we have some new functions. Let's go ahead and focus on wholes. Okay, we're gonna factor. So let's go ahead and factor this. I have x plus 2 in the top, nothing to factor. In the denominator, we can factor out a negative 4. We're left with x squared plus 3x minus 2. Oh, plus 2. Right, taking out a negative 4, so it changes the sign. Okay, I can factor the denominator now. Again, I already took out the negative 4. But 2 and 1 multiply to 2 and add to 3. So I have x plus 2 times x plus 1 after I factor that. Now remember, wholes show up when terms cancel out. And in this case, we have an x plus 2 and an x plus 2 that divides to 1. So my simplified function will look like this. 1 over negative 4 times x plus 1. And I know that I have a whole where my canceled terms equals 0. So to make that equal 0, that have to be negative 2. So I know the x value of the whole has to be negative 2. To find the y value, take 2 and plug it into the reduced function. So I'll have 1 over negative 4 times negative 2 plus 1. Okay, so that becomes 1 over negative 4 times negative 1, which is 1 over 4. So 1/4. That's it. That's the whole. We found the location of the whole. All right, let's do it again. We're going to factor on number 6. I have x times x minus 2. And in the denominator, first let's take out the negative. We're left with x squared plus x minus 6. What multiplies to negative 6 that adds to 1? Let's see, how about 3 and negative 2? All right, so let's go ahead and factor x times x minus 2 all over negative x plus 3 times x minus 2. We have our terms canceling out with the x minus 2, so we do have a whole. And we know that the x value of that location has to be 2. 2 comma what? Well, our reduced function is x over negative x plus 3. To find the y value of the whole, let's plug in 2. We get 2 over negative 2 plus 3. So 2 over negative 5, or negative 2/5. And that is how you find holes.